Hello everyone, I am Garima More. This is our fourth video of internal video explanation series day 2 test 2. Let's start. Question number first is discuss attribute by attribute problems that may have found into following database. Let us discuss attribute by attribute some of the problems that have found their way into the dataset. First, the customer ID variable seems to be fine. Second, attribute of zip. Here we are expecting all of the customers in the database to have the usual 5 numeral US zip code. The customer 1002 is okay. Now customer 1002 has zip code of J2S7K7. Unusual value may be an error or toss it out. Not all countries use the same zip code format. Actually, this is the zip code of Saint Hyacinthe, Quebec, Canada. So probably represents real data from a real customer. The customer 1003 is okay. For customer 1004, we are unaware of any countries that have four-digit zip codes, such as the 6269 indicated here. So this must be an error, right? Probably not. Zip codes for the New England states begin with numeral 0. Unless the zip code field is defined to be character, text, or not numeric, the software will probably chop off the leading zero, which is apparently what happened here. The zip code is probably 06269, which refers to stores, Connecticut. The income field is measuring annual gross income has three potentially anomalous values. Customer 1003, income of $1 million per year, possible especially when considering the customer zip code 90210. Beverly Hills, this value of income is nevertheless an outlier. An extreme data value, certain statistical and data mining modeling techniques do not function smoothly in the presence of outliers. Poverty is one thing, but it is rare to find an income that is negative, as our poor customer 1004 has. The The customers 1004's reported income of $40,000 lies beyond the field bounds for income and therefore must be an error. It is unclear how this error crept in, with perhaps the most likely explanation being that the negative sign is a stray data entry error. However, we cannot be sure and should approach this value attempting to communicate with the database manager most familiar with the database history. For customer 1005's income is 999 dollars. Perhaps it may in fact be valid. But if all the other incomes are rounded to the nearest $5,000, why the precision with customer 105? Often in legacy database, certain specified values are meant to be codes for anomalous entries, such as missing values. Perhaps 9999 was coded in an old database to mean missing. Finally, are we clear as to which unit of measure the income variable is measured in? Databases often get merged, sometimes without bothering to check whether such merges are entirely appropriate for all fields. For example, it is quite possible that customer 1002 with the Canadian zip code has an income measured in Canadian dollars, not US dollars. Fifth, the age field has a couple of problems, although all the other customers have numerical value for age. Customer 1001's age of C probably reflects an earlier categorization of men's age into a bin labeled C. The data mining software will definitely not like these categorical values in an otherwise numerical field, and we will have to resolve this problem somehow. Customer 1004's age of 0. Perhaps there is a newborn male living in Stores, Connecticut who has made a transaction of $1,000. More likely the age of this person is probably missing and was coded as 0 to indicate this or some other anomalous condition. For example, refuse to provide the age information. Of course, keeping an age field in database is a minefield in itself. Since the passage of time will quickly make the field values obsolete and misleading, it is better to keep date type fields such as birth date in database since they are constant and may be transformed into ages when needed. Sixth, the marital status field. Seems fine, right? Maybe not. The problem lies in the meaning behind these symbols. We all think we know what these symbols mean, but are sometimes surprised. For example, cold water in a restroom in Montreal or turn on the faucet marked C. Since the C stands for chaud, which is French for hot, thus, there is also the problem of ambiguity in about table. Thus, the S for customer 1003 and 1004 stand for single or separated. In our table, does the S for customers 1003 and 1004 stand for single or separated. 7. Transaction. The transaction amount field seems satisfactory as long as we are confident that we know what unit of measure is being used and that all records are transacted in this unit. Question number 2. Apply data wrangling process in following database. Table is given. There are six steps in data wrangling. First, data discovery. It is concerned with how to understand your data. It helps to familiarize yourself with data. Second, structuring. It is required to organize the data. Raw data is typically unorganized and much of it may not be useful for the end product. So it is essential for easier computation and analysis in later steps. Third is cleaning. Considering the situation of data cleaning, handling dates formatted in a different way, removing outliers that will skew result, formatting null values. In data cleaning step, we determine whether or not additional data would benefit the dataset. Fourth is validating. This step is similar to structuring and cleaning. Use repetitive sequences of validation rules to assure data consistency as well as quality and security. An example of validation rule: confirming the accuracy of fields via cross-checking data. Publishing. Prepare the data set for use downstream, which could include use for users or softwares. Sixth, documentation of steps and logic during data wrangling are an iterative process for a clean and usable data set for analysis. This process allows analysts to get the information they need out of a large data set, otherwise be unreadable. Data wrangling process for this question. First, all names are now formatted the same way, first name and last name. Phone numbers are also formatted the same way, area code ABC and XXX. Dates are formatted numerically, YYY, DD. States are not abbreviated. The entry for J.K. Agrawal did not have fully formed data. The area code on the phone number is missing and the birth date had no year, so it was discarded from the data set. Now that the resulting data set is cleaned and readable for deployment or evaluation. This is the final table. Question number 3. Consider following database. Apply any methods for finding out missing values. First, with user-defined constants with mean or mode, and third is with random draws from the distribution of the variables. First, replacing missing field values with means in second and fourth row, and replacing missing fields value with random draws from the distribution of the table of the variable in the table. Question number 4. Classify bank loan application by assigning application to one of the three risks. Use entropy and information gain approach. So the table is given in which there are six attributes: home, married, gender, employed, credit rating, and risk class. Uh, we have given number of example A is equal to 10, number of classes are 3, frequency of class A is 3, frequency of class B is also 3, and frequency of class C is 4. Overall information in the given data due to uncertainty of outcome regarding the risk class each person belongs to is given by I equal to minus 3 by 10 proportionate of log positive 3 by 10 minus negative 3 by 10 proportionate of log negative 3 by 10 minus 4 by 10 proportionate of log positive 4 by 10 is equal to 1.57. Let us consider using each attribute in turn as a candidate to split the example. Attribute 1 owns home. For value y, there are 5 applicants who owns home. They are in classes A is equal to 1, B has 0 and C has 2. Value for y, n There are 5 applicants who do not own home. There are in classes. In A is 2, B is 1, and C is 2. Then information gain for Y is 1.52 and information for N is 1.52. The total information of two subtrees are 1.52. Second attribute merit. For value Y, there are 5 applicants who are married. There are in class. For A is 0. For B, in B, B has 1 and C has 4. And value for N, there are 5 applicants who are not married. They are in classes. In A are 3, in B are 2, and in C is 0. So information for Y is 0.72222. The information for N is 0.971. Total information of two subtrees are 0.846. Now attribute 3 gender. For value Y there are 3 applicants who are male. They are in classes. A has 0, B has 3 and C has 0. Value equal to N. There are 7 applicants who are female. They are in classes. A has 3, B has 0 and C has 4. Information for Y is 0 and information for N is 0.983. Total information of the two subtrees is 0.69. Now we are considering attribute for employed as attribute for value Y. There are 8 applicants who are male. They are in classes. A has 3, B has 1 and C has 4. Value N. There are 2 applicants who are female. They are in classes. A has 0, B is 2 and C is also 0. So information for Y is 1.41 and information for N is 0. Total information of the two subtrees are 1.11 and attribute 5 is credit rating for value A. There are 5 applicants that have rating A. They are in classes A. In A there are 2, in B is only 1 and in C there are 2. Value for N. There are 5 applicants who have rating B. They are in classes in A 1, in B 2 and in C also 2. Information for Y is 1.52 and information for N is 1.52. Both are similar. Total information of the two subtrees are 1.52 male. Now we choose as gender as our information gain because it is the highest among all the information gains. Now we can reduce the data by removing the attribute gender and removing the class B since all class B have gender equal to male. Now uh, we we had got gender as a root node and married and class B as subnode. If rule if gender equal to male then class B, else if married equal to yes then class C, else class C. Attribute comparison based on information gain, not necessarily always fair. This approach favors those attributes that have large number of values. If there was an attribute that had a large number of values such that each value resulted in only one element of the dataset, then that attribute will be selected, although it might not be the optimum split attribute in the data. Question number 5. Compare the attributes of classification of bank loan application by use Gini index and information gain approach. Assigning application to one of the three risk class, compare the attributes of classification. So we have given total number of example as equal to 10, number of classes is 3, frequency of class A is 3, B is also 3 and C is 4. The Gini index for distribution of applicants in the three classes is 0.66. Now we are considering owns home at attribute as attribute 1. For value Y, there are 5 applicants. Similar to question 4, A has 1, B has 2 and C has also 2. Then value of when then we take N. In N there are 5 applicants and the classes A has 2, B has 1 and C has 2. The information of Y is equal to 1.52 and uh, information for N is 1.52. The total information of two subtrees are 1.52. Similarly, for merit attribute, total information of two subtrees are 0.846 and for gender Total information of two subtrees are 0.69. Thank you.